Hi, welcome back. So this is the fourth video in the full every topic of calculus AB review playlist. And we're going to be looking at finding tangent and normal line equations and approximations from those equations. So just to briefly mention this before we get into the first step, a tangent line is just a line that hits a graph at a point and is parallel to the graph at that exact point. And a normal line is the line that is perfectly perpendicular to the graph at that point. So the first thing we have to get, and we have to understand how to get to find a tangent line equation, is the POT, or the point of tangency. So the point of tangency is the point on the graph where the line makes contact with the graph. So for example, this point here. So what we need to do is take whatever information we're given. For example, we could be given the whole point. We could be given a question like find the line tangent to the graph of f of x. I wrote f of x up here so we could reference that. But it could say find the equation tangent to f of x at the point 4, 3, for example. And that would be our point of tangency. But alternatively, it could say find the tangent line, or find the equation of the line tangent to f of x at the point where x equals 1. So now we have the x value of our point of tangency, but we need to find our y value. So to do that, we just plug in 1 into f of x, into our equation, and we find that 1 cubed is 1 times 4 is just 4, minus 3 times 1, so it's 3, plus 1, so that's going to come out to 2, right? Yeah, 2. So our point of tangency would be 1, 2. And it would be the same thing if it gave us a y value. We'd just take the y value and replace it with f of x and then solve for our x value. So that is how you find the first thing that you need, which is the point of tangency. So the next thing we have to find our tangent line equation is the slope of the tangent line, or the SOT. So the slope of a tangent line is the same as just the derivative at that point. So we already have our POT. Let's say it was 1, 2 for the sake of this problem. So what we first want to do is find the derivative of f of our equation, f. So f prime of x is equal to 12x squared minus 3. And then what we're going to want to do is plug in the x from our point of tangency into the derivative. So that would be 12 times 1 squared, which is 1. So it's 12 minus 3 is 9. So this would be our SOT. So now that we have our SOT of 9, we can go and create our tangent line equation. But if we were alternatively asked to find the slope of, or the equation of the line normal to the graph, or the normal line, that means it's the negative reciprocal of the tangent line, or the slope is the negative reciprocal of the tangent line. So instead of this slope of 9, we want this slope of negative 1/9. So we would take the reciprocal, that's 1/9, and then make it the opposite sign, so negative. So that would be the slope of the normal line if you were asked to find that. So the last step, now that we have our POT and our SOT, is we want to make the equation of the tangent line. So we're going to use y minus y1 equals the slope, we'll call it m, times x minus x1. So y minus y1 would be 2 equals the slope, which is 9, times x minus x1, which is just the x coordinate, so 1. And then we could further simplify this into y equals 9 times x minus 1 plus 2. Whoops, that's out of frame. 9 times x minus 1 plus 2. And then we could further distribute the 9 if we needed to for any reason. but this is now our tangent line equation. And to just touch on this quickly, if you were asked to, for example, approximate the value of f of 2.1 or something like that based on the tangent line equation, all you do is take this value, plug it into the tangent line, and whatever your output is your approximation. So if that equals a value like x, then the approximation would be that same value.